Okay, here's our video review for exam 3. Um, and just before I get started on this, I will say that this exam really just boils down to two things, two skills. One, you have to identify the values in each question. For instance, what is R, what is T, what is P, and place them correctly in the formula. And then the other challenge is to enter them in to your calculator correctly. And I have tried to help out with both of those things, most especially the calculator. And so with each one of these questions, I have the keystrokes that you would put in to get each of these values. And the numbers, I haven't indicated them as separate button presses. I think we can all figure out that this is, you press the button 1, 0, 0, 0. But anything else, any other operation, any other key, I have put the symbol for those, and then I've put them in a little box so that tells you this is the multiplication key, this is the left parenthesis key, this is the addition key, etc. Excuse me. So, with that said, let me go through these questions, see how far we can get. In the first question, we have a simple interest problem. We have a simple interest exercise. So we have the formula here for simple interest. P is the principal. It's the amount borrowed or invested. R is the interest rate, the annual interest rate, and T is the amount of time in years. A, of course, is the amount that we end up with at the end, whether it's the amount that our investment earns or the amount that we have to come up with to pay off the loan. And so in our story, we have a fellow who doesn't know how to compute compound interest, so that's why he's charging simple interest, and the annual interest rate he's giving us is pretty ghastly. It's 50%, and he wants to be repaid in 6 months' time. And we've borrowed $1,000. So the principal is 1,000, and so that goes here. And the rate is 50%, which is, move the decimal place 1, 2 places to the left, and that's 0.5. And so that goes right here, 0.5. And then 6 months is 1/2 of a year. So for T time, we put a half right here. Well, 0.5 times a half is 0.25. When you add that to 1, you get 1.25. You multiply that by 1,000, and so in 6 months, our friend Guido here is going to want $1,250. So here are the keystrokes for that, and this is going to work in either a graphing or a scientific. The one button you might not need is the multiplication here, and you're definitely going to want it here, but you might not need the multiplication here because the calculators, both, I believe, understand that there is an implicit multiplication. If you put 1,000 and then a left parenthesis, they know that you want to multiply 1,000 times whatever you're going to put in your parentheses. And in any case, here are all the keystrokes. 1,000 times left parenthesis 1 plus 0.5 times multiplication 1, and then divided by 2, and then right parenthesis. Of course, a lot of this stuff in here inside these parentheses you probably could have done in your head or as scratch work before entering it into the calculator, but there are the keystrokes if you want to do everything all at once. And so now with no further ado, I'll move on to the second question. And in this question, oh, and I'm sorry, I will point out that I have the section indicated where you can look up various things that you might want to know, other examples, and so on for this type of question. Well, then the second question comes from section 3.2 because it deals with compound interest. And in this one, 5,000 is the principal, and that's identified in the question. And the rate is 5%, and it's compounded monthly. And we're asked how much is in the account after 4 years. And then we're also asked how much would be in this account if interest was compounded continuously instead of monthly. Well, here's our formula for periodic compound interest. R is the rate, 5%. M is the number of compounding periods per year. Well, there's 12 months in the year, and so that number is 12. So the rate at 5%, move the decimal place 2 places to the left, so 0.5, 0.05, and so the rate is 0.05. We divide by the number of compounding periods in a year, which for monthly is 12. Close these parentheses and then raise that to the number of compounding periods in a year, 12, times the number of years, 4. So that's 12 times 4. And now you could have multiplied 12 times 4, I think, and just use that in your exponent, 48. But 0.05 divided by 12, I'm not sure that divides out into a nice short decimal representation. I would still go ahead and do this inside the parentheses, all of this operation inside the parentheses for maximum precision. Now, here's the keystrokes for this calculation. I believe it works the same for the graphing as it does for the scientific, although that will be different here momentarily with one of the upcoming questions. So 5,000 times, which again, is maybe not necessary, but I put it in anyway, times left parenthesis 1 plus 0.05 divided by 12, close parentheses, and this is the little caret symbol, the exponent symbol, and then 12 times 4. Now, in the window of a scientific, at least in the window of the TI-30XS, when you press this key, there will be a little superscript. So there'll be a little area that'll come up, and whatever you enter in there is what's going to be in the exponent. And then you have to press the cursor key to the right to get out of that, but that's not going to be necessary in this case because the last key that you press is the 4, which is in the exponent, and then you hit enter and you get $6,104.48. And now for continuous compounding, we use this formula, principal times E raised to the rate times the time. And so we enter in 5,000 times. And then for a scientific, or actually for either of these calculators, you need to press the second function key. It's a yellow key on a TI-83 or 83 plus, and it's a green key on the TI-30XS. And that's the only TI scientific I have. I know that for other scientifics, the key might not necessarily be green, but you want to enter the second key, and then the button is going to be the LN key on both calculators, on both the graphing and the TI-30XS Scientific. And then that gives you the exponent, the superscript, this little guy right here up above the base is the superscript. And then you enter 0.05 and times 4, and then you need to close those parentheses for either calculator in order for the calculator to understand that you're done with that exponent. And again, that's the value that you'll get for continuous compounding, $6,104.01. Not a lot more than this, but a little bit more. Okay, and so now the third question will have a distinctly different keystroke entry for the scientific as it will as for the graphing. In this calculation, or in this question, we're asked to calculate APY, annual percentage yield. Those formulas are on your handout. For continuous, it's simply e to the rate, e raised to the rate, and then subtract 1. And for the periodic, you have 1 plus the rate divided by the number of compounding periods per year, and that, enclosed within parentheses, is raised to the number of compounding periods per year, and then that figure, from that figure we subtract 1. And so the rate for monthly compounding is 0.03. Monthly, of course, means 12. And so 0.03 does divide out nicely into a easily terminated decimal, 0.0025. And so if you want to, in your calculation, enter 1.0025 raised to the 12th, you can do that. But I've chosen for these keystrokes to do all the calculations in one fell swoop. So you have the left parenthesis 1 plus 0.03 divided by 12 and right parenthesis, and then you have the caret for the exponent, and 12 minus 1. Now you don't need to close that out there because the graphing knows the order of operations. The scientific does too, but it operates differently. The graphing knows that once you have done that and you enter a subtraction, you enter a minus, that it's going to make all these calculations first and then subtract the 1. Now for the scientific, everything is the same until you get to the end of the exponent. And you have to press the right cursor button and to get the cursor out of the exponent before you press the subtraction and the 1. And when we're done, the APY when compounded continuously is 0.03035, and when compounded monthly is 0.03042. Well, 42, that's bigger than 35, and so this is larger, and so compounding monthly, compounding 3% monthly is the better rate. True, that is not a huge difference, but bigger is bigger.